Good morning, class. So at this point we're looking at exercise or chapter 15 is the extension of trigonometry. Okay, at this point we have looked at the introduction to trigonometry and parts of your trig graphs. So now we're looking at chapter 15, which is heights and distances. So now we are told that in trigonometry, just right here, this is example 1. Page 343. So we are told in trigonometry you can solve the right angle triangles by using trigonometric ratios. That we have done already. 5.6, 5.5, and those exercises. Okay, we have dealt with this. If you are given a triangle, you're given an angle and the side. Then we could have used tan to calculate this unknown side, or we could have used opposite and hypotenuse to calculate that side. Not so. You can use sine there, or you could have used tan. And the unknown angle, you could have used sum of triangles. So at this point, we can solve right angle triangles. Not so. Calculating all the unknown sides and all the unknown angles, given certain conditions, of course. Not so. Then again, if you are given two sides, if you've got 5 and 4 here, you could have calculated that angle. Not so. How could we have calculated that angle? Because tan is what? Oh, sorry, she says. Cos. Why? So it's adjacent over hypotenuse. That could have worked at unknown angle. Of course, you could have worked the side out. How? Either by Pythagoras, or once we got that angle, we can either use tan or we could have used sine. Once we got the angle. Not so. So that is why they tell us at this point, you can solve right angle triangles by using trigonometric ratios. In this chapter, you will extend the skill by working with more than one triangle. Okay? You will also apply this knowledge to calculate heights and distance in real life type problems. Okay? So that is still coming. So let's see what they say here. So we are working in triangle. Let's make this a little smaller. In triangle ABC. So here's ABC. Yeah? We are told that AB is perpendicular to BC, which means to say it's standing at 90 degrees. So if that stands at 90, what do we know? We know we can use all three ratios, and we can use Pythagoras. Okay. We know that sine is opposite of hypotenuse, which is AB over AC, which is the hypotenuse, or it can be written as lowercase c. Remember that if this is angle C, lowercase c lies opposite. That's angle A, lowercase a lies opposite, and so on and so on. Okay? So that's that. Then we are told that cos of C is adjacent of hypotenuse, which is BC over AC, or A over B. And tan of C is opposite over adjacent, which is AB over BC, which is equal to C over A. Okay. Is this some refresher there? And here's the one I want you to write down. Okay, I would like you guys to draw this figure here quickly before I calculate it. You don't have to write down the introduction, all that. You'll read through it now. But I would like you guys to draw that figure quickly, okay? Yes?
I'm gonna do the graph.
Yeah. You say, how can you do that in the exam? When I already teach it now. You think with that? Ruthless.
No, the one that you
It's called
TRIGS.
trig rock.
Cartesian plane.
Yes. Working trigonometric functions in Cartesian plane. Yes. I told you. Listen, everything we teach you is examinable. Since you're writing tomorrow, it's not fair to give you some minus, but some one a bit easier. That was fair, no? Why is it not fair, Michael? No, I'm saying that this year you won't get something like this. You'll get the basics. A right angle triangle, and you must work out the side, you must work out the angle. Yes. Sorry? What did you say? What did she say? How can you not know what you laugh? Huh? Okay. Listen, if you don't want me to hear what you're saying, then don't speak so loud. Okay? It's ugly. Now I feel like a fool. Alright, so we are told in triangle ABC. AB is perpendicular to CD. So here I can apply Pythagorean and I can use your trigonometric ratios, and there, as you can see, it's right angle triangles. Okay. There are two triangles you can work in. Then the question says that ACD is 44 degrees, BCD is 53 degrees, and BC is 12. All that information is on the diagram. The question says, calculate the length of AC. The question says, calculate the length of AC. The question is determine AC. Now, if you're looking at AC, AC lies in triangle ACD. Not so. If you look at triangle ACD, what do we have? We only have the angle. So at least you need another side to calculate AC. Not so? So that's not going to work. So now let's go to another triangle and let's see. She's saying Pythagoras, can you calculate Pythagoras in this year? No. You don't even have one side, so how are you going to apply Pythagoras? Looking at triangle DCB, this triangle here. What do you note? We have a right angle here, there's D, there's 53 which is C, and B. Okay. What can we say? What can we say, people? What do you think I'm going to calculate here in that triangle? D? DB. Okay. If you got DB, how is that going to help us in the pursuit of calculating AC? Not going to help us. Nice. Okay. We're going to calculate DC. If you calculated DC and you have DC, then how is that going to help us? Then we will be able to go with adjacent and hypotenuse to calculate AC. Does it make sense? Okay, let's go again. If you look at the information that's on this diagram here, okay, clearly I can't calculate AC immediately. As you could see, when I worked in triangle ABC, I couldn't have done anything. As I said, if we just had another side or another side, then I should have been able to calculate AC. Not so. So looking at the other triangle, here, I remember this is 12 here, no? I can actually calculate DC and I can calculate DB at this point. But if I calculate DB, that is not going to help me calculate AC or determine AC. Why? So that is not the link between the two triangles. DC is the link between the two triangles. Can you see that, people? So which trigonometric function uses adjacent and hypotenuse? Cos. So you say cos of theta equals adjacent over hypotenuse. So you say cos. What's my theta angle? 53 degrees equals DC over 12. You all okay with that? So what do I do now? Cross multiply. So naturally that's over 1. Cross multiply. So 12 times cos 53 is 12 cos 53 is equal to DC. Therefore DC works out to be 12, make sure there's a D on top, cos 53. It gives us 7,22. 7,22. So how's that going to help us? Looking at this triangle now. This in triangle ADC. Remember the triangle is looking like this now. So we got the angle. What is this relative to the angle? The adjacent side, yes. And this here, AC is your? Not so. It's behind the calculator. Let's decide the calculator quickly. So let's go with it. Adjacent and hypotenuse. Which trigonometric function uses adjacent and hypotenuse? Cos. So again we say cos of theta, which is adjacent of hypotenuse. Theta is 44 degrees equals your adjacent, which is 7,22 over the hypotenuse, which is can you see that, people? So what do I do now? Cross multiply. And you punch it in the calculator once you've got AC at the side. Okay, so we cross multiply, we get AC cos 44 is equal to 7,22. How do we get AC on its own? Divide by cos 44. That's gone. So AC is equal to, now remember 7,22 was the last answer calculated in the exam, in the calculator. Not so? So now we say answer over cos 44. Close the bracket, gives us 10,04. Okay. So any confusion there? The question says calculate the length of AC. If they had asked the nearest meter, it would have been 10 meters. Okay. So let's look at 15.1. Let's do number 1 together. Exercise 15.1, number 1. Which page is this on? 344. Right. Draw this diagram quickly and give the reference there on top of your question. Always write which exercise coming from and the page number and all of that. Okay. So we don't write the full sum down. Alright. When you do your studying, you do it in conjunction with your teacher. That's all. Okay. So we told in triangle ABC. AC is 15. So AC is 15. Angle B is 47 degrees. Angle C is 17, which was on the diagram. And then we are told that AD is perpendicular to BC. The question says calculate AD. Calculate AD. So we're looking at AD. AD is this length here. So which triangle do you think we're going to work in? Is it ADB or ADC? Why ADC? Because yes, good start. Because what? You got enough more information in ADC than we have in ADB. Not so? So the question I'm asking you now, in which, if you're going to calculate that, what is that relative to this angle? It's your opposite. What do we have? We have that one. So which trigonometric function am I going to use here? Sine. So you use sine people. Okay, so it's going to be sine of 70 equals AD over 50. Cross multiply. So AD is equal to 15 sine 70. Put in the calculator, 15 sine 70 gives you 14,095. So it's 14,1. You all okay with that? So you put here 14,1 meters, no? Let's look at B. B asks you to work out BD. Do we have enough information to work out BD? Yes. How? In this triangle line, it's going to be opposite and adjacent. Which trigonometric function is that? 10. So let's go back. There's going to be 10 of 47 equals opposite, which is 14 over BD. That's naturally over 1, so I cross multiply. So it's going to be BD. Tan 47 is equal to 14 divided by tan 47, so BD is equal to 14 over tan 47. Okay, so that is going to be 14 over tan 47. (13, 1). You all okay with that? Let me erase this because I need to keep the diagram in focus. C wants you to work out DC. How are you to work out DC? Pythagoras. So this is in this triangle, no? So that would simply be 15 squared is equal to 14, 1 squared plus DC squared. Not so? So Pythagorean theorem, yeah? With ADC equals 90 degrees. So that would simply be 15 squared minus 14.1 squared equals the square root of that, gives us 5.1 meters. So DC will be 5.1 meters. D, they want you to work out BC, which is this whole length here. So BC is going to be 13.1 plus 5.1. Give me an answer of 18.2 meters. Alright, you guys understand? For more? You guys are writing tomorrow, not so? So, I'm not going to give you any work for tomorrow. We'll just we'll go through this exercise tomorrow together. Okay? People, enjoy the rest of your day. And don't forget to study for the exam tomorrow. Good morning, class.